This is a video of the photodiode circuit, the transmitter and receiving end. Right now, the waveform shows the signal at 10 kilohertz, and the cyan color is the output, and the yellow waveform is the input from the signal generator. As you can see that it's at 10 kilohertz. It's from 0 to 5 volts. And we're using the Schmitt trigger on the front end to the laser diode driver, and in place we have an LED. And the configuration is set up so I was testing both photo receivers. Right now I'm using the SFH213 photo receiver as opposed to the MDW photo receiver. This is just because it provided better output, even though the this photo receiver right here has a faster rise and fall time. But we're using this because it's more sensitive for this setup. And it goes into the TL081. I chose this op amp just because it provided for a cleaner filter. All this is it just filters out the higher frequency noise. It's important to note that the photodiode is biased at a reverse bias at negative 18 volts. The signal comes from the transmitter to the receiver, goes into the filter slash amplifier. It gets amplified from 0 to 5 negative. Gets amplified by 10 to 0 to 5 volts. Negative 5 volts peak to peak. Then it goes into the comparator circuit, which is I'm using the op amp on the Tri-RF DC board, and produces the 3.3 volt CTL high signal. So now I'm going to show you, as I ramp up in frequency, the response. Let's go to 100 kilohertz. Here's the response. Looks pretty clean. Let's also note the times when it's high and low is measured at 1.5 microseconds. Well, they're at 300 kilohertz, but right now you can see that they're pretty much similar. I'm going to 300 kilohertz. Produces the same output. There we go. And here now you can see at 300 kilohertz the times match up, as you can show by the cursor. Go to 500 kilohertz. Still pretty clean. And now we'll go to a meg, which is our current goal. And it looks good. And to demonstrate this is actually working properly, when I cover the LED, signal goes away. And I notice at 1.3 megahertz, 2, 3, the signal disappears. And the reason for this is because the TL081 has a gain bandwidth product of 3 megahertz. Therefore, when we try to amplify a square wave, we need out to the 5th harmonic at least. And not all harmonics are amplified because it's outside the range. So theoretically, we need an op amp that would give us about 5 megahertz gain bandwidth product to get all harmonics amplified and produce the square wave. And that was originally done with AD8030, which is this op amp right here. But the issue, it still can be done, but the issue seemed that TL081 provided as a better filter for the noise, provided a cleaner signal. And since our goal is only about a megahertz, this is suffice. So that's the system. It works. Now it's time to transmit some data.